Okay, it's a pleasure to be here. Can I just check that you can hear me at the back, okay? Yes, you can, all right. It's going to be fairly visual, so, you know, the main thing is up there, not me. I'm not quite sure what I'm going to talk about or what I was going to talk about, but I'm hoping that what I have to say is of interest. And that, first of all, an introduction to give you an idea of what sort of person I am. My great colleague, Sir John Cornforth, seen here at the age of 18, when he realized he was going to be deaf for the rest of his life, wrote an article in 1975, Scientists as Citizens, which I recommend you all read. It's on this website, vega, okay, .org.uk. It says that it may seem odd that a system of knowledge based on doubt could have been the driving force in constructing modern civilization. Scientists do not believe, they check. I'm not asking you to believe anything I say on a scientific matter, and I would say on any matter. As far as I'm concerned, it's always the same. Only that there is tested evidence for all of it, and I know the nature of that evidence and can make a judgment of its worth. Okay, so that's the start. Now the question is how I ended up as a scientist. I thought I'd go back to some images. When I was a kid, I didn't want to be a scientist. What I actually wanted to be was Superman. And here is the proof. You need evidence as a scientist. And in fact, flying was rather difficult, so I had to do other things like play tennis and gymnastics. And I acted in a play, Henry V. And I thought I'd show you. I'm the handsome guy on the right, just in case you don't recognize me anymore. But I always tell young people, you mustn't become an actor. You should do science, because the guy in front became an actor, and he's now 5,000 years old. I got an email from him this morning to say he's in New Zealand, and 1 week from now we'll have finished The Hobbit, and he'll be back in London. I'm a lot younger than he is, okay. Ian and I were in the same year at school, and he came out to Tallahassee, did a fantastic one-man show. So basically, my education was not in science. The main thing that I'm somewhat passionate about is actually art and graphics. And these are some of my posters when I was at university, and I was art editor of the university magazine. This got into an international professional annual of graphic design. My first award was not for science, it was for this design, and basically got into it. I used to look like this. And most of you are young and beautiful now, but you're going to look old and decrepit like me one day. So enjoy your beauty whilst you may. So these are some, I'm not quite sure what that is, but I'll carry on. These are some of my drawings. Margaret is over here, and I now do quite a lot of logo designs. This is for a buckyball workshop for children down in Australia. Designed a stamp for the UK, Nobel. This is my most recent bumper sticker, and I actually redesigned the Japanese flag, which is shown here. Okay. All right, so the other thing at university, you had to play the guitar. If you didn't play the guitar, you wouldn't be invited to a party, and you wouldn't meet any girls or boys. All right, so that's another thing. The other thing I did was photography, and I thought I'd show you what it was like to take a photograph in those days. And that's what you had to do to get a photograph. And to do all that, you really did have to have a pretty big incentive. And I had one, and she's over there at the present moment, okay? But today, all you need to do is that, okay? So your world is totally different. Majority, 99% of people have no idea what's going on inside the computer, the technology, the mobile phone, or anything else, nor do they care. Partly because they can't fix it. When you try to fix it, you have to throw it away because there's a new one there. So we're growing up with a vast majority of people with no reverence for the technology that is fundamentally underpins their life. And that's a massive problem, okay? Not the only one. The other thing, I was interested in architecture, and I drew this when I was about 13 years old, and this is Stockholm Town Hall, where the Nobel Prize was awarded. Not because I didn't know anything about the Nobel Prize, but I thought it was a very beautiful building. Le Corbusier's building, and Frank Lloyd Wright's Falling Water. Architecture at Sussex, which I played around with. But this particular building was particularly important in my science. And I want to stress this, that if you're going to do anything useful, you have to be extremely broad in your interests, okay? So those are the sort of things. The other thing I had was Meccano. And I built things with my hands. I thought I'd show you this advertisement, and I want you to compare this with the violent sort of video games that young kids today find. And in those days, Meccano boys, and of course nowadays you have to add girls, are keen, ambitious, and inventive. No boy or girl who follows the Meccano hobby can be a bad boy or bad girl, okay? And in fact, as a kid, I was making things with nuts and bolts, and my world was put together. I constructed things in a way that's almost impossible to do today. Now I construct molecules in chemistry with electrons and atoms. A quick and incomplete overview of my science. I was interested in carbon chain molecules, and my colleague David Walton synthesized them. And originally what was interesting to me was the vibrations of long carbon chains. It was just, you know, here's a skipping rope, you can watch the way in which the waves go across it. What happens with molecules? And I use quantum mechanics to understand that. About the same time, radio astronomy led to a breakthrough which basically we were able to study compounds and molecules in the space between the stars. And using this telescope, we were able to show that there were carbon chain molecules, and as they rotated, they could give out a photon which you could detect with the radio telescope, and you could actually detect the frequency very accurately. And we were able to show that there are carbon chains in space, okay? So in the space between the stars were these carbon chain molecules. I thought I'd show you this particular picture, partly because I used to have some hair. This is me, if you didn't recognize me. We were so excited it got into the local newspaper. And here in the Brighton Evening Argus, we discover, the newspaper says that the chemicals were discovered thanks to Canadian work in radio astrology, okay? I hope you know the difference between astrology and astronomy, but I'm not sure, and I know that 95% of people out there don't know the difference. They think they're the same thing. Or, in fact, there are 10 times as many astrologers as there are astronomers. Then, a little bit later, it was discovered that in certain stars, carbon was being blown out of these stars. So there are carbon stars in which you have helium, which is squeezed, 3 helium nuclei is squeezed into carbon. So all the carbon in your body was once synthesized in a star, all right? So that's where your atoms were created, in a star. The star blew up, blew your atoms out into space, and they ended up here. And you're lucky to be here. Now, that led to the discovery of C60, which I don't have time to talk about. But when we discovered it, one of the crucial observations was this, which led to our decision as to what the structure might be, because it has the same basic geometrical pattern as a soccer ball, and that's the molecule that we discovered, and that led to the award of the Nobel Prize to 2 American colleagues and to me in 1996. I'm not sure why, because it's a bit like a supermodel. It's beautiful and does bugger all. But anyway, that's the situation. That led to a whole new area of chemistry. And I want to stress it was vibrations. We weren't setting out to discover that molecule. We weren't setting out to create a whole new area of chemistry. It started off originally just to understand molecular dynamics. I'm coming to perhaps the most important part of this talk, and it's about thinking. There are 3 senses. One is common sense. Now, what is common sense? Common sense tells us that the sun goes around the earth. Who agrees with me? Common sense, the sun is over here. Well, who knows where it is here? And it's somewhere there. Common sense says that the sun goes around the earth. And for thousands of years, that's what people assumed. It's uncommon sense. It's uncommon sense which indicates that the earth is turning on its axis, which makes it seem as though the sun is going around us. The uncommon sense and bravery of Copernicus, Galileo, and Giordano Bruno. Copernicus was dead before he published his theory. Galileo was threatened by the Inquisition, the Catholic Church, and Giordano Bruno was burnt to death by the Catholic Church for this. So you owe these guys a debt, okay? Because you're now allowed to question. You were not allowed to question at that time, and there are many countries at this present time where you're not allowed to question. Carlo Ponti's a film on Giordano Bruno ends with this. So you get an idea of what it was like in the 15th century when dogma ruled the world. Watch the film. It's on the internet. Most people, and I think everybody in this room, has accepted the claim that the earth goes round the sun without knowing the evidence. How many people know the evidence? Put your hand up. Nobody. Almost nobody. One or two people. Who knows the evidence? What else have you accepted without evidence? I want you to think about that, because 95% of the planet accepts a lot of bullshit without evidence. And if you don't think that's dangerous, you've got another thing coming. Many people accept claims for which there is no evidence. Think about it. The Royal Society's crest is, take nobody's word for it. Nonsense is common now. All right. My favorite quotation is by Don Marquis, okay? And it applies to this particular part of my talk. If you make people think they're thinking, they love you. But if you really make them think, they hate you. And I'm in the middle of something like this by email, because I've been making this guy think, and he doesn't like me very much because of it. So basically, I'm not here to make you feel comfortable. I'm here to make you think. Okay? My colleague, Capoconto, who we just mentioned earlier, in this article says, that's the one you've already got. Sorry, I should have moved that on. Okay? I moved it forward. The thinking is dangerous, as we saw. Giordano Bruno was burnt to death for this. Let's talk about science. There are aspects of science, and one is the body of knowledge that we learn at school, the known. There's the application of that knowledge, which is technology, and the ways in which knowledge was actually uncovered, the scientific method. Those are three pretty distinct, separate aspects. However, there's something far, far, far more important. And because science is so useful, people have forgotten the most important aspect of science, the cultural, the intellectual aspect of it. And particularly people in positions of authority, like politicians who know bugger all about science. Almost nobody, probably few of you even here in this audience. And what is it? Before science became useful, it had another name. It was called natural philosophy. And the most important aspect by far is the following. Natural philosophy is the only philosophical construct we have devised to determine truth with any degree of reliability. I'm going to define it. There is a philosophy, there is a method of determining truth with a degree of reliability. I'm going to call it natural philosophy. I'm not interested in anything else. Nothing else concerns me as far as the value and truth. That should be self-evident, okay? And the ethical purpose of education must involve the teaching of young people how you can decide whether what you're being told is actually true. All right? And therefore, the teaching of a skeptical, evidence-based assessment of all claims, without exception, is an intellectual integrity issue. Surely truth should come before everything else. All right? Without evidence, anything goes. Think about it. The freedom to doubt. Richard Feynman, in The Meaning of It All, very small book, well worth reading, he says, the freedom to doubt is an important matter in the sciences, and I believe in other fields. It was born out of a struggle. It was a struggle to be permitted to doubt, to be unsure. And I do not want to forget the importance of that struggle and by default let it fall away. We are in the process of seeing that falling away. The Enlightenment is under threat by people who do not recognize the dangers that are stalking the world, particularly Europe at the present time. If you know that you're unsure, you have a chance to change the situation. I want to demand this freedom for future generations. That's for you to question, all right? Okay, so that's Feynman. The Walt Whitman, the great American writer, I think encapsulated what science was better than anything else. He says, I like the scientific spirit, the holding off, the being sure, but not too sure. That's the great writer, the double take. The willingness to surrender ideas when the evidence is against them. This is ultimately fine. It keeps the way beyond open. If you have a philosophy which does not respond to the evidence when it is against it, then the way beyond is not open, and you're locked for centuries and millennia in dogma, which is what a large amount of this world is at the present moment locked in. Okay. Intrinsically impervious to rational criticism. Even some scientists who should know better do not appreciate this, as is obvious by what they write. Feynman, now, in this bit of film, says...
If you're interested in the ultimate character of the physical world, or the complete world, and at the present time, our only way to understand that is through a mathematical type of reasoning, then I don't think a person can fully appreciate, or in fact can appreciate much, of these particular aspects of the world, the great depth and character of the universality of the laws, the relationships of things, without an understanding of mathematics. I think it's just, I don't know any other way to do it. We don't know any other way to describe it accurately and well, or to see the interrelationships without it. So I don't think a person who hasn't developed some mathematical sense is capable of fully appreciating this aspect of the world. Don't misunderstand me. There are many, many aspects of the world that mathematics is unnecessary for, such as love, and which are very delightful and wonderful to appreciate and to be awed and mysterious about. And I don't mean to say that the only thing in the world is physics, but you were talking about physics, and if that's what you're talking about, then to not know mathematics is a severe limitation in understanding the world.
It's a fantastic film. If you get to watch it, you should do so. However, he points out that if we look at our technological world, that you need mathematics to understand it. It's the language. And if you want to understand English culture, you have to learn English. If I want to understand Estonian culture, I have to learn Estonian. But it's not so important if I don't know Estonian, because I don't have interaction here. But if politicians and business people and administrators are making decisions and they don't understand the language of the technology and the science that underpins our everyday life, there's a big danger. And I think it's certainly true that although knowledge doesn't guarantee good decisions, common sense suggests that wisdom is an unlikely consequence of ignorance. And 95% of politicians are totally ignorant about science. Okay. The orderly harmony of what exists. Let me just give you an example of fantastic science. The numbers 1, 3, and 5. Here are 3 sets of boxes. In fact, what we know is that the Earth orbits the Sun, and we use classical mechanics for that. An electron orbiting a nucleus, we use quantum mechanics. According to quantum mechanics, if something is spinning in quantum systems, which are very small atoms, there are only certain orientations which are allowed. If you don't know quantum mechanics, don't worry, but nevertheless have a look at this, because it's actually very simple. If you want to understand how computers work, you have to learn a little bit of mathematics, and it's not very difficult. The angular momentum is quantized, and there are 2 j plus 1 orientations. So when j is 0, a spinning object essentially has only one orientation. If spinning with 1 quantum of spin, it has 3 orientations, and when it has 2 quanta of spin, it has 5 orientations, hence 1, 3, and 5. Let me double that set, okay? Double that set and double this set, move this to that and this to that. Double that set, double this set, move this to there, and that to there, and what have we got? I'm just interested whether anybody knows here. Yeah? Well, I think somebody knows. It explains the whole of chemistry, all of life, and all the useful bits of physics, if any. Okay. Well, of course, physics is basically science of the universe, and chemistry is that massive part of science, of physics, which applies to you, to the food you eat, the chemistry, the thermodynamical things, the car moving, the food you eat and how you actually live and the processes in your body. That's called chemistry. There are some students who actually appreciate this, and here we see some of the tattoos on this. I mean, there's actually a mistake here at that point. Well, actually, it's just a missing minus sign. Maxwell's equations, DNA, Heisenberg uncertainty principle, LSD, if you want to synthesize it in the break. And also here, the Taylor expansion of sign. I want you to read through this. Nicole, a physics graduate student, my tattoo is the Taylor expansion of sign. I consider it the most beautiful thing I have ever learned. Now, how many here would say the most beautiful thing you've ever learned is a mathematical equation? It's not funny. Because this language is the language which underpins your world. You may have found a beautiful piece of poetry, but it doesn't underpin your world. So people like this who change the world, okay? The birth of natural philosophy is very interesting. If we go to Abelard in the 12th century, he wrote in a book, Sic et Non, by doubting we come to inquire, and by inquiry we arrive at the truth. And this is a very short and simple explanation of science, really. And doubt and questioning are intrinsic threats to the power of those who depend on dogma for their authority. That's politics, capitalism, socialism, religion, and other dogmas. Abelard got into a lot of hot water and more, as some of you might know. Francis Bacon, the 16th century philosopher, in his books, defined the scientific method. And the interesting thing, it was called novum organum. And in Latin, that means new instrument. Science did not exist before the 15th, 16th century. There was common sense. People cut people open. They thought the sun went around the earth. You have to look under the surface, under the carpet, to find out how the universe works. And most people don't like what they see, because what they see makes them feel uncomfortable. This new instrument was very important. Basically, observation, hypothesis, supporting evidence, physical law. If we invert Abelard's statement, we have a profound axiom. To determine truth, we must doubt and inquire. And that has explosive consequences. The new instrument intrinsically undermines the assumptions and claims that had held sway heretofore before the 15th and 16th century, and that fundamental truth was to be found in the Holy Scriptures. Okay? That's why there was a conflict from the 15th and 16th century with Galileo, Copernicus, Giordano Bruno, and it exists today in spades. The conflict between those who use evidence to decide what is true and those who accept bullshit. All right. All right, so that's it, Giordano Bruno for one. And it is interesting to note that only where natural philosophy has undermined the power of dogma-based authority is where we have democracy and science. It doesn't exist anywhere else. And who are they? Well, there's even a misconception of who the scientists are. For instance, this is a typical image of a scientist, okay? He looks more like a politician to me than a scientist. Okay, this is a typical one as well, okay? This is disturbing because scientists don't look much different from anybody else, in my experience. Can we shake off this mad media image? And there we have a typical picture from Back to the Future. And the guy who's responsible is this. And this guy is actually an imposter. He didn't do all that relativity stuff. It's actually this guy who did it. And in fact, it was young Einstein. And in fact, he was 17 when he started to think about what it was like to travel at the velocity of light. Okay? All right. It's young people who do it. Darwin, who wrote this book which has had revolutionary consequences. This book changed our whole picture of who we are, how we arrived here, and a lot of people don't like it. He was a young man of 24. Clerk Maxwell, who created these equations, every time those mobile phones, how many there? Oh, every time those mobile phones run, they prove that this is a fact, that these equations are followed, the electromagnetic equations of Maxwell. That is evidence, okay? It works. Wee Jamie, with a little quiff on the top of his head, okay? He was a young Scotsman. Rosalind Franklin took the most important image of all time. From this image, the structure of DNA was determined. This structure will have profound consequences in your lifetime and forevermore. We don't have the wisdom to make decisions, wise decisions, on how our knowledge of this structure and its implications for the way life can proceed, the control we shall have possibly over our own offspring. We don't have the wisdom to that. Science is uncovering knowledge which will give us profound problems in the future, and already is doing. Chandrasekhar was a young man when he discovered that a star 1.5 times the size of the sun would collapse into a neutron star. It's young people who change the world. The other thing about science is that it's international. I know you guys are all bound by some business thing, but we are bound by an intellectual culture. The truth, the way the universe works, and from all over the world. That's what I like about science, because it doesn't matter what country you come from, it doesn't matter what color you are, it doesn't matter what religion you have, whether you have one or not. Most 90% of top scientists don't have a religion. Truth is more important than anything else. Some of the gifts of science to society are interesting. For instance, anesthetics. There were no mobile phones. And have a look what it was like to have an amputation before anesthetics 150 years ago. Women had a mastectomy without an anesthetic. Think about it. There are people in this room who will have operations. You owe a tremendous sort of round of applause to chemistry, because that's got to be one of the most humanitarian contributions. Penicillin. There's probably not a single person in this room who has not had either an antibiotic or someone in their immediate family. In fact, because of this and anesthetics and sewage disposal and our chemistry and physics and engineering, it is the fact that basically half of this room would have died by the age of 8 in the 18th century. Okay? That wasn't done by politics. It was done really by science, technology, engineering, applications to society. You don't need to pray. Blood poisoning in 1942. A year earlier, this little girl would have died. In 3 weeks, she was cured with penicillin. One of the heroes of that story. The future, bacteria are evolving with an immunity to antibiotics. Think about it. There are people trying to been contending for President of the United States who don't believe in evolution. All right? We're probably going back to this because of evolutionary processes. Science in the 21st century. Well, you've heard about nanotechnology, but people don't understand what it is. Basically, let's think about this. Would it be possible one day to create a computer by bottom-up chemical assembly? All right? Well, it's already been done. Basically, your brain has been created protein by protein on the basis of a DNA blueprint into some sort of computing system. So it should be possible for us. Okay. Well, what about this? Okay, genetic engineering by humans. Without any knowledge of DNA, this has been made into a chihuahua. Okay. And we can do that in one step. We can probably make a human being into a chihuahua as well. And there are a number that I suggest we do that too. Okay. So a good definition of nanoscience and nanotechnology, and the one I prefer, It's not the only one, but it's the most powerful and understandable one. It's atom by atom, molecule by molecule assembly of a complex and/or functional system. By that definition, you are the results of nanotechnology. You've been created protein by protein, assembled on the basis of a DNA blueprint. That's nanotechnology. Yes, it's small things, but small things like bricks build up to big things like buildings and human beings. Just one little indication of what we're doing. This is a ferrite core memory, and when the first ferrite core memories were developed, they were in a matrix, a lattice with these little magnetic ferrite cores, and if you pass half the current down one of these and the other half down that you need to magnetize the core at the same time, then you can magnetize them. That could be a storage element, okay? What we're doing is actually trying to make, by chemistry, basically little connected ferrite core magnets. We're making a little bit of progress. We're about 1 to 5% on the road. My favorite molecule is not C60, which led to this prize, but it's actually this molecule because it looks like this. It's actually my dog, made of carbon, hydrogen, okay, red nose. I can look at the spectrum and show the dog shakes its head and actually looks at its tail. All right, okay. It's not only that, my dog actually is quite clever because it can undergo what's called internal rotation. And it's actually been drinking too much beer. It's a cold evening in Tallinn, and you know what the problem is. You've been drinking too much beer, and you're a dog. You desperately need a lamppost. Now, the point is that molecules are flexible, and that is something that's not really been exploited. And in fact, in your body, hemoglobin is a flexible molecule too. And if we look at the most amazing molecule of recent years, the development of an understanding of the structure of ADP synthase, you are all driven by ATP, adenosine triphosphate. ADP plus phosphate goes to ATP. So this is the source of all the energy. As I speak, as your brain runs, as you move your arms, as these runners run around tracks for some reason I don't really understand, but basically here, ADP, adenosine diphosphate, goes into these cavities, and adenosine triphosphate comes out. What is happening is that protons are going onto this wheel and turning it round. It's an electric motor inside your body, and you've got millions of those driving you. You are driven by electricity, not by electrons, but by protons in aqueous solution. These motor enzymes are now being exciting things, and if I were thinking of becoming a scientist, I might like to play with that. Come to the last part of what I want to talk about, it's education. I do workshops all around the world, okay? I don't talk about quite such serious issues. I don't make these kids feel uncomfortable. I try to make them enjoy some science, make things. Mexico, Malaysia, by internet to Iceland, across the whole of Australia, and in the UK, and with Manchester United's Diego Forlan, who got the golden boot when he's now playing for Barcelona. This is my favorite guy because he's found a use for our molecule, the only person to do that, okay. We have a setup now which is being reproduced around the world. We use a capture station. I don't need to be here. You're looking at this thing here most of the time, and so on the internet, I go by internet now several times a year. And in fact, these parts of this lecture are already out there. It's the future of broadcasting. All right. Now, it's also greenish because I don't have to travel, right? And we've been in 11 countries in just under 8 weeks, and too much traveling. It's GeoSet, G-E-O-S-E-T, and I hope you're going to consider doing this here. So what is it? Well, let me show you an undergraduate. We're recording on undergraduates, okay?
Here are the Beatles. George, John, Ringo, and Paul. We all know their music, and most of us even know of their impact on the world today. However, whether we realize it or not, we've had more contact with another type of beetle, and they have had far more influence on our very lives. I'm talking about these beetles, the insects. And this presentation will be all about the one...
I'm going to stop it there because I want to show, that's an undergraduate, I want to show a graduate student.
Hi, My name is Terry Gilmore, and I am a graduate student here at Florida State University. I work for Dr. Al Lugan as an organic chemist. Now, I love organic chemistry because it provides you the opportunity to go through and be an architect, an engineer, builder. You can go through and you can really look at designing molecules. We can figure out how to actually make these molecules, and then finally, we actually get to go into the lab and actually build these things. Now, the greatest organic chemist by far is nature. Nature can go through and take something as utterly simplistic as these small seeds, and through a series of organic transformations using chemistry that we ourselves use, it's able to go through and transform into these beautifully complex and beautiful flowers that you can see here. Now, what we do is much the same. We'll take something relatively small, something relatively simplistic, and through a series of transformations, we need to figure out how to make something that's much larger, much more complex.
I'll jump on.
If we add more triple bonds in this case, we could go through and fully zip up these structures. We could go through and take something, instead of just making it relatively small and close it up, we can extend that all the way through and form much longer chains. And, you know, that's fun.
Okay, now, we're recording our undergraduates, we're recording our graduate students, we've got a fantastic set of fascinating little projects, 5 minutes to 7 or 8 minutes by students and by teachers. And what have we done? We've revolutionized the resume. We're putting our students on top of the pile. Because not only are they a pile of paper that someone has to spend some time reading this bloody stuff, they can sit and watch them on the web. You can see Kerry and others as well. And here is the evidence for why you should consider this. Kerry, who you've just seen, got a Fulbright scholarship to Italy. Steve helped us get a GSM Rich Media Award. Prajna Dar, an Indian student, has now got 4 tenure-track offers, has now got a job at an American university, and they told her that from the internet we can see you can teach. Brittany got into Dartmouth Medical School, and the presentation was the defining factor. Jeff said, I think it's helped me get my position. It was fun to do it. This is an interesting one. Artrees was one of my students. She went down for an interview. They'd already seen her presentation, and they said they enjoyed it. She'd already got the job with him before the interview. She was head and shoulders ahead of anybody else. Okay. Jennifer just got into vet school. Daniel's just got a Goldwater Scholarship, the most prestigious scholarship in science in the USA for undergraduates. This is an interesting one. We've got Japanese Node Noriyuki, he got his job at NHK. And this is the one that you need to look at because this is the future. Sayano is an Indian postdoc who was in Japan, recorded on our GeoSet sort of node in Japan. It was sent to a university, Mahatma Gandhi, where she wanted to go, and she's now an assistant professor there. She didn't have to go. She was on top of the pile. Otherwise, she'd just been a pile of paper. This is now 90% of the resume. And then they look at it and say, well, this is interesting. This woman can teach. This is a sort of, she's got an interesting project. Let's have a look at the resume. My colleague, Mark Riley, and this is for people around here, he records his students and sends it to NSF. If you were recording the projects of this group here, they would be part of the report to show that you were doing something useful and would be much more easily, and most of these reports, as you well know, are not read. Okay, that's the situation. Assessment, you got a pile of paper, there's hundreds of students over there. If they'd all done a little, you could all sit there having, as I am here, sitting having a glass of wine and enjoy the presentation, okay, instead of wading through piles of paper. If you want to know what I'm doing here, because there are a few tricks of this trade, on the GeoSet site, I'll tell you 5 little tricks about presentation, okay. Steve Aqua, Sam Ruston, Colin Byfleet and Penny Gilmer are the people helping me. And Margaret here is the person that, while I'm here, because I didn't know where I was going. So if you don't like it, it's her fault. If you do like it, it's her fault as well. Okay. We've got nodes all over the world. In the USA, in Brazil, in the UK, in Japan, opening up also in Spain and Japan. Okay. The last two things I want to say. The unpredictability of major innovation. Well, here is Ian McKellen again. And I want to stress that the original aim in my research was to understand vibrations, quantum mechanics, fundamental science. That led to radio astronomy, and we discovered carbon chains in space. Then the carbon chains were discovered in stars. In trying to simulate the conditions in a star in the laboratory, we discovered the C60 molecule by total accident. By thinking about what the structure might be from architecture and also models that basically I built, Margaret had bought this model for our children and I made it up with them, we decided we knew what the structure might be. Okay, and then we discovered it was a soccer ball. All right, amazing. That led to a whole new area of chemistry. I didn't set out to do that. I didn't set out to do any of those things. And the final aspect is this. It's been found by another group that fullerenes improve the plastic solar cell efficiency. And I want you to think about innovation. Because most of people who think about innovation, most of the administrators, most of the politicians who are in control of the money think you can think of something you've never even thought about and discovered and applications long before you knew what the hell you were doing. Okay? Ridiculous, stupid, and obviously so. And if you get into positions like that, I hope you'll recognize that that's a problem. And so all that is gold does not glitter, and not all those who wander are lost. I like that line. Not all those who wander are lost. That's what science, real science is. And it goes on, this poem. It's in the Lord of the Rings, and you can find it on the web. Attitude. I don't have anything over you guys. I know this. Most people I have ever met are at least as smart, if not smarter than I am. So it's attitude. I've only one piece of simple advice. And that is, if you're going to do something, give it your best shot. If you're satisfied with a second-rate effort, then give that up and try to do something. Find something where only your best shot will satisfy you, not the teacher. Then they're irrelevant. It's you personally that matters. And I don't mean enjoyment. Do something you enjoy. I don't enjoy hard work any more than anybody else does, okay? What it is something that you're so engrossed in that it's like 5 or 6 o'clock in the afternoon and you haven't been for lunch and it doesn't matter. Or you're working in the evening and you go to 2, 3, or 4 o'clock in the morning and you're so engrossed in it, it's so interesting. And then you flop in bed and you don't really like going to bed so late. That's not what life's about. There's not a lot of enjoyment around at the moment. But there's a satisfaction that comes from doing a job as well as you possibly can. And if you take that, I think you'll do well, or certainly better than others. Others could do something better than you, but they don't have your determination, if you have that determination. So the only thing I have is that attitude. I think that's important. The last thing I want to say, there are responsibilities that you have, because we're now in an age of powerful technologies. There are various organizations which you should consider thinking about and working with in some ways and in a little bit. There are the International Network of Engineers and Scientists for Global Responsibility. If you're a physicist, we don't need any more atomic bombs. We've already got 30,000 of them. There are 3,500 ready at this moment to be set off in 45 seconds. Just think about it. If you could get a Taliban guy into all these places, just one, you could actually obliterate the world in the next 45 seconds. These things are there. And it's almost a certainty that another Hitler will come along, and the fact that these weapons are there, they will use it. All right? That's why I think we should think about it. If you're a chemist, we don't need any more napalm. This iconic image tells us everything. And if you're an engineer, we don't need any more landmines. You can see photographs and film of little kiddies playing soccer with one leg blown off by a landmine. And whether they're lucky to be alive, I don't know. So technology is powerful, but by and large it's politicians and other people in position, industrialists, who make these things, okay? They use the science we know. Leon Lederman, friend of mine, Nobel Prize in physics in 1988, sent me an email a few months ago. He says, Harry, say this whenever you give a lecture. So many years have passed, and the human race is still saddled with enough nuclear weapons to destroy the planet. We must redouble our efforts to unify the science community against this huge stupidity. Not just the scientific, we're only 1%. 1% change the world. We can't stop the use of that technology. It needs a lot more people. My close friend in the last years of his life, Joe Rotblat, is shown here. He got the Nobel Prize for Peace with pugwash and tried most of his life, last 50, 60 years, to stop the proliferation of nuclear weapons. The only scientist, perhaps bar one other, to leave the Manhattan Project when it was clear that the atomic bomb was not necessary and before it was completed. Unfortunately, all the other scientists decided they'd finish the job. In his Nobel address, he says, we appeal as human beings to human beings. Remember your humanity and forget the rest. If you can do so, the way lies open to a new paradise. If you cannot, there lies before you the risk of universal death. The quest for a war-free world has a basic purpose, survival. But if in the process we learn how to achieve it by love rather than by fear, by kindness rather than by compulsion, if in the process we learn to combine the essential with the enjoyable, the expedient with the benevolent, the practical with the beautiful, this will be an extra incentive to embark on this great task. Above all, remember your humanity and forget the rest. Anyway, last things I want to say. My favorite poster is this one. I'm an alien creature. I was sent from another planet with a message of goodwill from my people. The message says, Dear Earth people, when you finally at last destroy your planet and have no place to live, you can come and live with us. And we will teach you how to live in peace and harmony. And we will give you a coupon good for 10% of all deep dish pizzas to, sincerely, Bob. Destroy the planet. I'm not sure, but it don't look good, okay? The voracious use of fossil fuel is worrying. Climate change, it's happened many times before. Are we responsible? Could be. I'm a scientist, I'm not sure. We're on a 100, 200-year experiment. I'm sure about this. It is ludicrous that in the 21st century, with weapons of mass destruction, and in the future biological weapons and chemical weapons, that we still solve our problems by sending young people like you to go and kill each other. Pretty incredible, isn't it, when you think about it? That politicians, our democratic process, produces people who can't sit down in a room and solve the problems together. And finally, sense of humor and the pizza. Without the pizza and a sense of humor, I don't think life's worth living anyway. So that's the situation. Leonard Cohen in Rolling Stone said, I don't consider myself a pessimist. I think of a pessimist as someone who is waiting for it to rain, and I feel soaked to the skin. Okay. Well, me, I'm an optimist. I'll be well out of here when the shit hits the fan. Level of optimism. Thank you very much.